What are imaginary roots in algebra quadratic equations? Have you ever wondered what happens when a quadratic equation doesn't have real solutions? Let's unravel the mystery of imaginary roots together. Imaginary roots appear in quadratic equations when the solutions involve the imaginary unit I, which is defined as the square root of -1. This situation arises when the discriminant, which is the expression under the square root in the quadratic formula, is negative. To break it down, quadratic equations are typically written in the form of a times x squared plus b times x plus c equals 0. Here, a, b, and c are constants. To find the roots or solutions of the equation, we use the quadratic formula. X equals negative b plus or minus the square root of b squared minus for times a times c, all divided by 2 times a. Now the discriminant, which is b squared minus for times a times c, tells us about the nature of the roots. If the discriminant is positive, we get 2 distinct real roots. If it is 0, there is one real root, which is a repeated root. But when the discriminant is negative, we step into the realm of imaginary roots. When the discriminant is negative, the square root part becomes the square root of a negative number. This is expressed as the square root of negative d equals I times the square root of d, where d is a positive number. Consequently, the roots take the form of a plus or minus by, where a and b are real numbers and I represents the imaginary unit. These roots appear in pairs known as complex conjugates, such as negative to plus I and negative to minus I. For instance, let's consider the quadratic equation squared plus for x plus 5 equals 0. The discriminant here is for squared minus for times 1 times 5, which equals 16 minus 20, resulting in -4. Using the quadratic formula, we find the roots to be equals negative for plus or minus the square root of -4, all divided by 2. This simplifies to negative to plus or minus I. Imaginary roots are significant because they broaden our understanding of solutions beyond just real numbers. Every quadratic equation has roots in the complex number system, which is guaranteed by the fundamental theorem of algebra. This theorem states that every polynomial equation has at least one root in the complex numbers. In practical terms, if a quadratic function has imaginary roots, its graph will not intersect the x-axis. This means there are no real solutions where y equals 0. Instead, the parabola will lie entirely above or below the x-axis, depending on the leading coefficient. Grasping the concept of imaginary roots helps learners see that algebraic solutions can exist outside the real number line. This knowledge lays the groundwork for more advanced topics involving complex numbers and functions. So, the next time you encounter a quadratic equation with imaginary roots, remember that it opens up a whole new world of mathematical possibilities.